start the class with the Umul Kitab, Al-Fatiha. Okay, so let's continue our lessons on chapter 3. So we will continue again. I should remind you that we already learned the chapter 3, but during our first week. So this is the continuity of the chapter 3 about the projectile motion. So let's take a look and take a deep look in terms of the videos. Okay, so please watch the video. And of course, I will stop later.
Assalamualaikum and salam sejahtera. My name is Zuhairus Nizam bin Madarus. Today we will continue chapter 3, motion in 2 dimensions. In this section we will cover subchapter 3.1 and 3.2. 3.1 is displacement, velocity and acceleration in 2 dimensions. And 3.2 is 2-dimensional motions. Learning outcome. First, define distance, displacement, average speed and average velocity and average acceleration. Second, to describe projectile motion, launch at different angle and height in 2 dimensions graphically. Third, to solve 2-dimensional problem by applying kinematic equation of motion with constant accelerations. Motion in 2 dimensions. By using positive or negative sign is not always sufficient to fully describe motion in more than 1 dimension. So, vector can be used to more fully describe motion. And we're still interested in displacement, velocity, and acceleration. Displacement. Look at the figure. The position of an object is described by its position vector r. And the displacement of the object is defined as the change in its position delta r equal Rf minus Ri. Rf is final position and Ri is initial position. Unit of the displacement is meter. Velocity. The average velocity is the ratio of the displacement to the time interval for the displacement. V average equal to delta R over delta T. And the instantaneous velocity is the limit of the average velocity as delta T approach to 0. And the direction of the instantaneous velocity is along a line that is a tangent to the path of the particle and in direction of motion. The unit of velocity is a meter per second, m over s. Accelerations. The average acceleration is defined as the rate which velocity change. A average equal to delta v over delta t. And the instantaneous acceleration is the limit of the average acceleration as delta t approach to 0. And unit of the acceleration is meter per second square or meter m per s square. The summary of the unit for displacement is meter, average velocity and instantaneous velocity is meter per second, and average acceleration and instantaneous acceleration is a meter per second square. Where an object might accelerate, the magnitude of the velocity or the speed may change with time, and direction of the velocity may change with time even though the magnitude is constant. Both the magnitude and direction may change with time. Projectile motion. Projectile motion is motion in two dimensions, which means at any point all the quantities, velocity and displacement can be resolved into two components. That is the horizontal and vertical component. At the initial point, the component of initial velocity u or v naught can be resolved into two components. That is v naught cos theta has the horizontal component and v naught sin theta has the vertical component. Assumption of projectile motion. First, we may ignore air frictions. Second, we may ignore the rotation of the Earth. With this assumption, an object in projectile motion will follow a parabolic path. Rule of projectile motion. The x and y direction of motion are completely independent of each other. The x direction is uniform motion where ax equal to 0, and the y direction is free fall where ay equal to negative g, and the initial velocity can be broken down into its x and y component. V naught x equal V naught cos theta is a x component, and y component is V naught y equal V naught sin theta. Look at the diagram. The particle that leave the origin with a velocity of V naught, not that V change with time. However, the x component of the velocity Vx remain constant in time equal to its initial velocity V naught x. Also, Vy equal to 0 at the peak of trajectory. But the acceleration is always equal to the free fall acceleration and acts vertically downward. The figure shows that the projectile motion at various initial angle. Complementary value of the initial angle result in the same range. The height will be different, and the maximum range occurs at a projection angle of 45 degrees. This is the summary of the projectile motion. X direction, Ax equal to 0, Vx equal V naught x equal V naught cos theta equal to constant, and x equal V naught x times t. This is the only operative equation in the x direction, since there is a uniform velocity in that directions. And in y direction, V naught y equal to V naught sin theta, and this is a free fall problem, therefore A equal to negative g. And take the positive direction as upward and uniformly accelerated accelerated motion, so the motion equation are full. And the velocity of the projectile at any point of its motion is the vector sum of its x and y component at that point, where v equal square root vx square plus vy square, and the angle theta is the inverse tangent vy over vx. And you have to remember to be careful about the angle of quadrant. And the summary, provided air resistance is negligible, the horizontal component of the velocity remain constant. Therefore, Ax equal to 0. And the vertical component of the acceleration is equal to the free fall acceleration, therefore equal to negative g or negative gravity. And the acceleration in the y direction is not zero at the top of the projectile trajectory. The vertical component of the velocity Vy and the displacement in the y direction are identical to those of freely falling body, and the projectile motion can be described as a superposition of two independent motions in the x and y directions. This is the strategy to solve a problem. First, you have to select a coordinate system and sketch the path of the projectile. Include initial and final position, velocity, and acceleration. After that, resolve the initial velocity into x and y component, and then treat the horizontal and vertical motion independently. Follow the techniques for solving problem with constant velocity to analyze the horizontal motion of the projectile, and follow the technique for solving problem with a constant acceleration to analyze the vertical motion of the projectile. Some variation of projectile motion. An object may be fired horizontally, and the initial velocity is all in the x direction, v naught equal to vx and vy equal to 0. After that, all the general rule of projectile motions apply. Look the example 3.2 in your textbook. Stranded explorer. The goal of this example is to solve a two-dimensional projectile motion problem in which an object has an initial horizontally velocity. The problem: a rescue plane dropped a package of emergency rations to hikers stranded in the Australian outback as shown in figure. The plane is traveling horizontally at 40 meters per second at height of 1 times 10 to the power of 2 meters above the ground. Neglect air resistance. A. Where does the package strike the ground relative to the point at which it was released? B. What are the horizontal and vertical components of velocity of package just before it hit the ground? And C. What the angle of the impacts? Okay, first find the range of package. Use the equation delta y equal y minus y naught equal v naught yt minus half gt square. and then substitute y naught equal to 0 and v naught y equal to 0, and set y equal negative 1 times 10 to the power of 2 meter. And then the final vertical position of the package relative to the A plane solve and solve for the time. Use equation delta x equal x minus x naught equal v naught x times t, and then substitute x naught equal to 0, v naught x equal to 40 meter per second, and the time 4.52 seconds, and the answer is 181 meter. For B, find the component of the package velocity at impact. Package velocity at impact. And find the x component of velocity at the time of impacts. So Vx, from equation Vx equal V naught cos theta equal 40 meter per second cos kosong, cos 0 equal 40 meter per second. And Vy equal V naught sin theta minus Gt equal 0 minus 980 meter per second square, and time 4.52 second. So we have negative 44.3 meter per second. And C, find the angle of the impacts. Okay, and tangent theta equal Vy over Vx equal negative 44.3 meter per second over 40 meter per second, and we have negative 1.11. To find the theta, apply the inverse tangent function to both sides. Therefore, theta equal negative 1, theta equal inverse tangent negative 1.11. So we have negative 48.0 degree. For non-symmetrical projectile motion, we have to follow the general rule for the projectile motion and break the y direction into part, up and down, and symmetrical back to initial height and then the rest of the height. Look at the example 3.5 in your textbook, page 67. Example, a golf ball leaves the ground with a speed of 30 meters per second at an angle of 30 degrees above the horizontal.
So, okay, so let's stop at that example. So let me discuss or explain to you about the projectile motions. So in projectile, we will learn some things in two axes, two dimensions, which means you have x axis and y axis together simultaneously. Okay, so before this, okay, we already learned motion in one dimension, meaning that all movement involve either x axis alone or maybe y axis alone. Okay, you already did that part. Okay, you try to move the things, okay, in x axis, so that means there is motion in one dimensions. And if you try to discuss about free fall, so you also discussing about motion in one dimension but in y axis alone. Okay, so how about projectile motions? So basically, projectile motions will involve some things, will involve the same equations, but right now you should focus on simultaneously having two exist at one time. Okay, so let's look at. Okay, so let's say one moment. So let's say okay. So in motion in two dimension, we have a x and y axis that act simultaneously. Okay, so in motion in one dimensions, we have v equals to v naught plus at. Okay, v square equals to v naught square plus 2a delta x or also delta y, and we also have x or y equivalent to x naught or maybe y naught plus v naught t plus half at squared. Okay, all equations is in one dimensional motions. Okay, so what happened to the motion in two dimensions? Okay, what happened to the motion is two dimension is right now when you do have a system like this. Okay, so let's continue. I give you one. Okay, motion in two dimension will appear or will occur during like this. Okay, so if you throw a ball, if the object is moving at a certain angle, okay, at a certain angle like this, let's say theta equals to 30 degree or theta equals to, so you can see figure A, this is figure A and figure B. So maybe if you are throwing a ball or throwing a rock or maybe throwing things, okay, on top of the building, okay, to the floor, okay, to the ground level. So that's also uh, involve projectile motions. So again, you can see on the figure C, you can see a ball or a rock, maybe a thing, have been thrown horizontally. Okay, this one is thrown horizontally. Okay, horizontally. So what means by thrown horizontally? Meaning that okay, we throw okay the object horizontal. Horizontal means it should uh, equal to the axis of x. So that means horizontal. So that's also involve projectile because when you throw the ball or you throw the things horizontally, occasionally the things will be going down because of the factors of gravity. So of course dia akan jatuh ke bawah. And maybe if you have a problem, maybe you have a one thing problem, let's say you try to you play the basketball and you want to bounce, okay, meaning that you throw the ball, okay, throw the to the floor first and the ball will bounce to your friends. That is also involve a projectile motions. So in projectile we have a few cases that involve projectile. So these are the cases that we should at least try to make sure that we do understand each cases. Okay, so in projectile again, okay, we will see, okay, and you do have v equals to v naught plus 80. So this is the equations that we want to produce. Okay, so the equations is at least this equation you already learned in motion in one dimension. So therefore in projectile, so we will see what happened when it expand to x and y axis. So let's look. So let's say we try to expand these equations in x and also y axis. So what happened is just put the x subscript to each parameter. So let's v is vx equals to v naught x plus a, you should put x, and t. Okay, vx equals to v naught x plus axt. Okay, look at t. Time doesn't have subscript x. Why? Because time regardless of the x-axis or maybe y-axis, okay, it doesn't be influenced by the axis or the dimension. So time still be time. Either is x-axis or y-axis. So for y, we can have Vy equals to V naught y plus Ayt. Okay, just do it like that, right? And then we have a second equation, which is V square equals to V naught square plus 2A delta x. So what happened if we put in x and also y? Again, so this is Vx square plus equivalent to V naught x square plus 2ax delta x. And how about y? So we can have Vy square equals to V naught y square plus 2ay delta y. Okay, remember y is a small subscript. Okay, ay means a for acceleration and y axis. So the last part will be if you do have x equals to x naught plus v naught t plus half a t squared. So what will happen? Then you have x and y axis. Okay, so this one should be x equivalent to x naught plus v naught x t plus half a x t squared, and this one will be y equals to y naught plus v naught y t plus half a y t squared. Okay, so right now from three equations, okay, when three, I should write down in the blue box. So this is the equation, okay, the original equations. Okay, we have original equations. Now, these three equations have been expanded until you have six equations altogether. But for projectile alone, okay, how to do in projectiles? So projectile is where you can have ax is equivalent to 0 and also ay equivalent to negative g. Okay, so the concepts of projectile is ay equals to negative g and ax will be equivalent to 0. So what will happen to the original equation? So let's look. So use equation number 1. This is equation number 1. Number 2 and number 3, you can have here this one become 0. Okay, when this one becomes 0, so everything will be 0 at ax. Okay, because ax is equivalent to 0. So what happened? So we try to write down the new equations such as Vx equals to V naught x. And what happened to the second equation? Vx squared equals to V naught x squared. And the third equation, it will be x equals to x naught plus v naught x t. Okay, that is the only equations involved, right? So for ay equals to negative g, that you should be able to understand this. This one should be negative. Okay, so what happened? So we can straight that write down as vy equals to v naught y minus gt, and this y equals to vy squared equals to v naught y squared minus 2g delta y, and this one will become y equals to y naught plus v naught yt minus half gt squared. So right now you have already expand the equations from 3 to 6. Right now, okay, you should do some ramifications for the equations. Make sure that it follows the projectile motions principle. Okay, meaning that ax equals to 0 and ay equals to negative g. So what is the equations now? Right now we should have v x equals to v naught x, vx squared equals to v naught x squared, and x equivalent to x naught plus v naught xt. And in y-axis, we have vy equals to v naught y minus gt, vy squared equals to v naught y squared minus 2g delta y. And lastly, we have y equals to y naught plus v naught yt minus half gt squared. So right now, okay, we already discussed about the 3 equations. Right now become 6 equations, and this is the equations that specifically inform to solve the problems for projectiles. And please also remember that in projectile we do have v naught x. So what is v naught x? Is basically, okay, when you throw the ball, so with a v naught initial velocity, so there will be a, okay, v naught x, because this is theta, so we can have v naught y. So what is v naught x? V naught x is v naught cos theta, and v naught y is v naught sin theta. Okay, so please remember these equations. We should be able to derive this equation, because this 1, 2, 3, 4, 5, 6 equations, okay, it will not be given on in your appendix. Okay, kat appendix awak tak ada 6 equation ni, tetapi dia hanya ada 3 equation yang asas. So the derivation of this equation, you should do it by your own. Okay, so jangan terkejut lah, memang tak ada dalam appendix kamu. Okay, so make sure kamu buat tahu macam mana nak nak dapatkan 6 equations yang macam ni ya. Okay, so these are the 6 equations involved in projectiles. Okay, so let's look at the topics. Okay, let's look at the one examples that I want to highlight today. So okay, take a look at these examples. Okay, please snap it first before I close it to show the working. Okay, please snap. Tolong snap dulu buat soalan ni. Lepas ni kamu boleh refer dia dalam phone ke dan sebagainya. Okay, please take these questions. And of course, I will try to explain thoroughly from 1 until 5. Okay, so let's do the questions. So the question will ask you about a golf ball. Okay, golf ball have been launched at a certain initial velocity at 30 meter per second at theta equals to 30 degree. Okay, so that will be the only questions, okay, inside the problems. Okay, and of course above the horizontal, so you can see this is above the horizontal, theta is above the horizontal. Okay, let's look question number 1. Okay, the question asks you about a horizontal and vertical component of initial V naught. Horizontal and vertical component. So in the projectile, please make sure you should be able to point out, or you should be able to understand the whole concepts, okay, the terms especially. Okay, when they ask you about horizontal component and vertical component of initial velocity, that means, okay, they doesn't want to know about V naught, but they want to know, okay, so V naught, okay, but horizontal. What is V naught horizontal? So that's what we call as V naught X. Okay, so horizontal component for V naught is V naught X, which means horizontal is in X and Y axis. Okay, so V naught, now you have V naught X, V naught equivalent to V naught cos theta. Okay, so which means V naught cos theta is what? 30 cos 30 degree, so that will give you 25.98 meter per second. Okay, and how about V naught y? Okay, so the V naught y is equivalent to V naught sine theta, which means V naught is equivalent to 30 sine 30, that will give you 15 meter per seconds. Okay, and how about B? Okay, the velocity at the height of 5. So the velocity at the height of 5 meters above ground. So what does it mean by 5 meters? Okay, anyone? Height of 5 meters means you want to find X or to find Y? Anyone? What is 5 meters means? 5 meters means Y or X?
Y.
Why?
Y. Why? Because
Because
what?
Above ground.
it's high.
It's
Yes, it means
vertical component.
yes, it use height. Okay, it use height. Height means Y. Okay, Y is equivalent to 5 meters because in projectile you should know, you should understand that every time you want to calculate maybe distance or maybe velocity, make sure you calculate the time first. Okay, so in this case they want to find the velocity. Okay, the velocity meaning that there is no other keywords. There is no keywords such as horizontal velocity or vertical velocity. So it just take the calculate velocity. When you try to calculate the velocity, velocity means, okay, so when you do have v, definitely it will involve vx square plus vy square. Okay, because in projectile, okay, it doesn't come alone with velocity because velocity must come together with the components. So it will definitely comes with vx and also vy. Okay, so how to find vx? So vx is equivalent to, based on our vx is, you have two equations which is exactly the same. So vx is equivalent to v naught x. So what is v naught x? V naught x is 30 cos 30. So we'll give you 25.98 meter per second. Okay, how about vy? So Vy, in this case, we have a certain equation. For example, we have this Vy equals to V naught y minus gt, and we also have Vy square equals to V naught y square minus 2g delta y. Okay, we do have both equations. But how to use that equation in better way? Okay, kita nak pakai yang mana satu? Yang ada T atau yang tak ada T? Agak-agak?
Tak ada.
Kita nak pakai yang mana untuk soalan nombor 2 ni?
Tak ada.
Dalam soalan dia ada mention T tak?
Tak ada.
Tak ada kan? So macam mana kita nak calculate T? Kalau kita nak calculate T, nak calculate Vy lagi. So we have two variables. Okay, you cannot have two variables. Make sure the equations tally with your problem. So in this case, we will use Vy square equals to V naught y square minus 2g delta y. For those who doesn't like g, maybe they can easily use plus 2a delta y. It doesn't matter because a is equivalent to negative g. The same thing. Okay. So in this case, you should know 5 meters above the ground. Okay, so we need to find Vy. So Vy is equivalent to the square root of, what is V naught? V naught is 30 sine 30 square minus 2g 9.8 times with 5. What is 5? 5 is 5 minus 0. Okay. So that one will give you, okay, from the calculations will give you about, let me look at the answers, 11.26 meter per second. Okay, so how to solve the problems? Yes, again, we should put the value of, okay, 25.98 square plus 11.26 square. So that will give you 28.32 meter per second. Okay. And lastly, okay, I think we don't have much time. Okay, we should continue later during our class on Thursday. So let's continue on C. So C asking about the maximum height. The maximum height and the coordinates at that point. What's the meaning of maximum height? So in projectile, okay, when the ball leave the ground and goes back to a certain angle. So let's say the ball had leave here. So on the tip of the parabolic path, or di atas tu, we can say this is the maximum point. Okay. What happened at maximum point? So at maximum point, Vy will be equivalent to 0. Okay. So Vx is always equals to V naught x. So Vy equals to 0. And of course, we have to find, according to the question, we need to find what is the coordinates of x and y. So in order to do that, we should find what is y. So we should get using the equations. So the maximum height and the coordinate at that point. So when at the maximum height, what should we do? Okay, we should find using the equations involved, or the equations as a lot of equations. So we need to select the right equations in order to solve this problem. So in this case, okay, we want to find y. So we can easily using this kind of equation, maybe vy Vy squared equals to V naught y squared minus 2g delta y, because in this case, it only involves V naught and also Vy and y. So at the maximum point, Vy will become 0. So 0 equivalent to 30 sine 30, okay, square minus with 2, 9.8 times y. So in this case, y will be equivalent to the y will be equivalent to 11.47 meters. So that will be y. How to find x? Okay, how to find x? So in order to find x, we should find t at that particular point. Okay, we need to find what is time at this point. So how to do that? Okay, maybe we can use Vy equals to V naught y minus gt. Okay, because you know Vy is equivalent to 0, so Vy is equivalent to gt, and t is equivalent to V naught y minus over g. So that means the answer should be equivalent to 1.53 seconds. So that is not the answer yet, because we want to find what is x. So x is what? According to the equation, x is equivalent to x naught plus v naught xt. So we should write down as x naught plus v naught xt. So what is v naught? 0 plus v naught x. So v naught x is v naught 30 cos 30 times t, 1.53. So the answer should be equivalent to 39.72 meters. So that will give you the coordinates. So you must answer it. Okay, the coordinate will be equivalent to 39.72 and of course 11.47. So that will give you the value for the coordinates. All right. So I think that's enough for today. If you have a question so far, okay. If you do have questions, make sure that you put in inside. Okay, maybe later on when you watch the video again, make sure you put inside the Google Classroom, or maybe you put inside the your future. Okay, I should remind you about the you should be you should undergoes a quiz. Okay, you should answering the quiz on Wednesday. I will tell you exact time. I think around 8 o'clock. Okay, so please be ready. I will inform you later. I will give you official announcement. Yeah, for our quizzes. Okay, so please get ready. Please be ready. Make sure the quizzes only involve tutorial one. Okay, do some revisions on tutorial one and chapter one together. Okay, so I think I will stop here because you don't have questions. So I think that's all for today. Thank you very much. Thank you for your attention. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam. Thank you, sir.
Bisa.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.